Hi learners, welcome to balance scale classification. As you know, we have all the AI modules over here, starting from data science, computer vision, and natural language processing. And today we will be discussing about balance scale classification, which is an intermediary data science algorithm. Going through this, as usual, we have these 5 steps, starting from about to model, data sourcing, model building, data visualization, and deployment. Balance scale, it is to identify the scale position, whether it is balanced or not. This is usually what we see in shops or somewhere. So we have left data and right data, and we want to identify whether the scale is balanced or not. Okay, so going with that, this is a data science model. We are using machine learning. It has both categorical and continuous variables, and we would be predicting the accuracy. On the data set side, we have left weight, left distance, right weight and right distance, and the class. Actually, the left side weight will be in the grams, but we would be converting that into categorical values, so that eventually we have this class, whether it is balanced or right-sided or left-sided output. So this is a supervised learning. We have the output or the target variable given here. We follow 5-stage approach: data sourcing, where we are interested in finding out the source of the data, how to get the data, and right form of data. All those things will be taken care by data sourcing, followed by EDA and feature engineering. Here in the EDA, we have variables, interdependencies, cleaning, and then feature extraction, and eventually we would conduct the feature engineering so that the predictability power of the data set will be high. Algorithm selection, here we are interested in finding out the right algorithm. As we always say that sometimes you could select more than one algorithm for the problem, but upon various iterations or out of your experience, you will understand that particular algorithm could fit, be it classification, be it regression or clustering, whatever it is. So algorithm selection is a very important part in the data science especially. And model optimization, here we would be hyper parameter tuning, or tuning the parameters for the better accuracy and output. In this, we would do various iterations to get the best output, and eventually that would be passed on to the deployment. Here it is the user side. It may be deployed on the web, cloud, or the server side. So customer would be interacting with your model directly over here, and we would be giving you the data and code, source code, for you to use in your future applications. We have introduction that gives you entire details about the how we are doing it, and data sourcing, what is the type of code we are doing, the libraries and all. Model building, for this particular model of balanced scale classification, we are using KNN, K-neighbor classifier. We would be defining that, and followed by the code, data validation. So you could explore all these things until deployment, and eventually you could even get the balance scale data set link through the GitHub. Once you're ready, move on to the data source. Here we are defining the data set: L weight, L distance, R weight, R distance, and class. As I mentioned, the weights should be in the grams. It were converted into categorical values of 1 and 2, and so you could see that all the 4, and it is completely a categorical data, including the target variable of class. This is a supervised learning. Moving on, we have model building. Here we, as we learned with any other model, we have train set and the test size. Usually for the training purpose, we use 70/30. You could use 80, and obviously it will become 20. So we will keep it there. And parameters, if you're interested in knowing what kind of classification or algorithm we are using here, we are using KNN, and you have neighbors as parameter, weights, algorithm, and so on. This documentation will help you to understand and learn much about the algorithm before even you working. Here is a intermediate level, so you could do some modifications here. It is a KNN we are using, and then you could change nearest neighbors, or you could take the weight distribution uniform, or distance method, and then nearest neighbors, you could select how many nearest neighbors. And After doing a lot of modifications, if you're not sure, then click on the reset. It will reset to the basic versions to start somewhere. And once you're ready, check the accuracy. For this model, we are showcasing 83.5%. Again, you could improve that by playing around this with values. And there goes the confusion matrix showing you the performance and the errors over here. So this is a pretty decent one for learning. So 83.5, and with confusion matrix of this sort, it is looking good. I would move on to the next part or the step, where here I am doing the data validation. I am playing like a user. I could change my L weights and then L distance. I could play around with this. R weight, right side, and R distance. Okay, I could do that. And then once I'm ready, I would just predict, and it is saying that for the given input, the machine could be left-sided, and the probability is saying for. So if I change it to left side weights, I will change it to R distance as that, and it is changing to the right side, and then the accuracy or probability is increasing. So this way you're playing around with these input values to see how the model is performing. That's what we are doing here. Once it is done, we are going to deployment. Here we have dataset and source code. You could go to GitHub and get the data, or Jupyter Notebook and directly download the file in Jupyter format, and then PDF and Python as py format code. So you could take this code and eventually try to solve another problem or modify it as you like. So we encourage students to take the code and work upon that.